Good morning, everybody. Oh, you are awake. I heard rumors that some people went to karaoke last night. Was that you? I got photos this morning from a friend who was also at karaoke the night before. I'm so grateful that you are here for the second talk. Some people even turned up for the first talk today, which was amazing. I would also like to point out that while it sounds like I have a deeply sexy, husky voice made for radio, it's not because I was at karaoke last night. It's actually because I've got a bit of a head cold that I'm recovering from. I wish I had been in karaoke last night, but unfortunately that's not the reason for my voice. So if my voice breaks at any point, I will endeavor to repeat myself, but please bear with my frailty at the moment. Anyway, thanks for coming along to my talk this morning. We want to talk about clean code. Has anybody, I'm going to try and see hands, has anybody heard of clean code before? Okay, about 70% of you. That's pretty good. Has anybody heard of it but isn't implementing it at the moment? About half of you. Okay, so we've got a good mix of people here. Some of you are using it already. I'm glad you are. Hopefully you'll be able to use it in all of your projects. Some of you aren't. I basically want to take you through today the basic principles of clean code, what the benefits are. We'll go into some statistics because we all like numbers. We're all software engineers. We like a bit of stats to back up our claims. We'll go into some justifications if you need them. We'll look at the whole process of if you haven't done it before, what is it? What are the benefits? How can you start implementing it? How can you start persuading somebody that you should implement it? And obviously the main reason we all want to be here is because we want to find out how to be that hero. Who's already a hero? Only 3 of you. Okay, we'll change that today. Who am I and why am I here talking to you about this today? My name is Ben. Hello, nice to meet you. I've been a software engineer since, I used to count the number of years. Do I have the number of years in there? No, I've actually changed it to the year because it was a little depressing for this number to get higher and higher. It made me feel my age. But I've been a software engineer since 1999. I actually started in VBASP. Thank you. I was waiting for the commiserations. Luckily, I only did it for about 6 months before I then moved on to PHP. Poor thing. I know. And as you can see here, I'm a security and privacy advocate. I'm a developer advocate. Used to be a developer advocate for Auth0. I'm now a developer advocate for Sonar. I like to work with tools that help developers be more secure, more effective, more productive, those kind of things. But prior to becoming a developer advocate, and the reason why I got into it is that passion for privacy and security. I used to be a developer. I used to be a solutions architect and a business analyst. I was a security consultant for a while. I've touched a lot of areas of business as I've gone through my career. I'm definitely one of those jack of all trades, master of none. I haven't dived very deep. If you ask me about security, I'll talk to you all day long. If you want me to rootkit some server, I've got no idea where to start. I don't have that level of depth, but I've touched a lot of different systems, a lot of different teams, a lot of different projects, and some of the things that I've noticed over time is that the way we design our software, the way we code our software, we often get to the point where working on that code again at some point in the future or starting a new project is an overhead that we don't necessarily enjoy. Nowadays, we've got bootstrapping mechanisms, we've got frameworks, so it becomes easier, but it's still not necessarily as easy all the time. So I've taken reflections of those and tried to work out where I think clean code comes from, is going to what we can do with it. Somebody did ask me yesterday, are you going to be fanboying some guy who wrote a book about it? Oh, hello there. No, I will not. If you came here for a fanboy talk, I will not be at all offended if you decide to go and grab a snack or something. Because I want to talk about my experiences of it and how it can potentially help you. Anyway, enough about me. Let's look at the problem. What is the problem that clean code actually solves? How many of you have had to open a project that the code you haven't touched for at least a year? Yeah, about half of you. I think the other half of you are either fairly new to software engineering, in which case, welcome, or you're lying. Because we've all had to open this code at some point where we've gone, what the hell did I do here? I've got no idea what this line of code does. You go and you do a git blame to find out whose fault it was, and it was mine. So we've all been in that position. The other situation we might have as well is that maybe there's a project that's quite old and a bug has been raised. one of your teammates was working on it and now you have to work on it, and it is somebody else's code. And ideally, they've written it in a way that you can actually understand what's going on. You've got commenting and documentation, all of those kind of things. Or maybe you work in a digital agency and you work on 5 projects at a time, and you're context switching and moving between them. And maybe they're in different languages, maybe they're the same language, but they're all different sets of business logic, and you're trying to remember exactly what you did where and why that order over there is a different kind of order to that order over there, because context matters. So I went to have a look for some statistics, because we all love stats, right? So the developer coefficient is a report that was issued by Stripe, and in it they basically, have a look at those numbers there, 51% of our time as developers, of our work week, not just our developer time, of our entire work week, is spent working on bad code, debugging, refactoring, and technical debt. That's probably a worst-case scenario. If you're working on the same project for a couple of days, that will improve. But picking up something from scratch or starting something from that either you've worked on before or somebody else has been working on, you're going to be spending more than half of your week just getting up to speed and trying to work out where the hell you have to start. Another analysis of how software developers spend their average week. If you have really good eyesight, you will see that one of them in there, I don't have really good, the first one, in fact, is handling interruptions. I don't think they mean like software interruptions. I think they mean meetings, going to the toilet, going out for a coffee, lunch breaks, whatever. But on average, we spend 16% of our time coding and 45% of our time reading code. That means we're reading code 3 times more than we're writing it. It's not necessarily a bad thing, it's just what we do, right? 22% of our time is spent on interruptions, which again is meetings, and that kind of stacks up with my experience of probably about a day a week, if I compressed my calendar, would be meetings, and then the rest of my time is working on other stuff. So that probably kind of adds up. But if we think about these two numbers, so if we look at the time coding and the time reading code, and we add those two together, that's 61%. And we had 51% of the time looking at bad code and refactoring code and maintaining code, which leaves 10% of the time of our week that we're writing new code, new functions, or remediating in some way that's not actually a maintenance item, but like changing functionality. We're creating utility for the business that we're working for. 10% of our time. That's 4 hours a week that we spend writing meaningful code. Again, worst case scenario, but I don't think that's what Tim Ferriss meant. I think he wanted us to have the rest of the time off, not working on the stuff we don't want to work on. So, like I say, not every week's going to be like this. Sometimes you're working on a proof of concept, and that's going to be a very different scenario to working on code that might be bad or needs refactoring. Sometimes you're starting a project from scratch. Sometimes you've been working on something for a couple of days, and it's in your brain again. That context has switched, and it's easier to get back into the code the next morning when you arrive at work. My brain just automatically said the words when you arrive at work. When I arrive at work, that's when I go downstairs with my coffee. Has anybody had to go back to the office yet? Some of you? I'm sorry. Unless you enjoy going to the office. I mean, some people do, and that's great. I very much like being able to roll out of bed in the morning and go straight into my office. Anyway, so we've got this problem. We've got this scenario of the stats they are against us. We're only spending 4 hours a week on this productivity. So how is clean code going to come to the rescue? Let's have a look, first of all, at what clean code is. If you had to write a sentence about what clean code is, you could quite arguably get away with writing something like, it's well-structured, readable, easy to understand, follows naming conventions, has consistent formatting, and is properly commented. What can you tell me about that sentence? Does anything stand out to you about... The last line. The last line? Properly commented? Normally we shouldn't write comments. The code should be comments. Kind of. The main thing here is this has nothing to do with the computer. The computer doesn't care if your code is well formatted or well structured or well commented. This is all about how humans look at the code. There's a guy, Donald Knuth. He's an American computer scientist and a professor emeritus at Stanford University. He was actually called the father of the analysis of algorithms at one point. And he said this: programming is not about telling the computer what to do. It's about telling another programmer what the computer should do. At the end of the day, programming is essentially storytelling. We are all storytellers. So let's change context in our heads for a second. Imagine you're a storyteller, not a programmer. Maybe you're an author, and you're writing a book. And you're writing a book with somebody else. You're co-authoring. And the other person has started a bit of the book already, and they're going to send you that book for you to be able to work on. Imagine if you receive a book that's in 25 different pieces, the appendix and the bit that goes to the front, again, head cold, brain not working, table of contents, are both together at the front. The middle chapters are the end, and you're trying to work out, where do I add my bit of information into this book? You're probably going to have to rejig their work a little bit before you can actually do your stuff. You're probably going to have to spend probably a few days just piecing it together and working out what's going on. It's not an ideal way of working on a book. I would imagine if anybody here has been a co-author, you usually use an online Word document type editor, and you would have everything in the correct order. You'd have almost like an agenda. You would have a structure, and you would be filling it out and padding it out in places. You would have structure from the beginning. That would essentially be a clean way of writing a book. So how can we do that with software engineering? If we do that with software engineering, or the code that we write, we're going to make we're going to get immediate benefits from that. One of them is going to be improved productivity. By writing code that is easy to understand and maintain, as developers, we're going to be faster and more efficient. In the same way as writing a book that's already linear for you, it's going to be easier to write software when it's well structured. It used to be, and I hope there are at least a couple of people in here who share my age range. It used to be that we wrote software that was optimized for computers, because we had so little memory on there that having a short variable name was actually beneficial, because we could write bigger programs because they took less space per feature, something like that. Nowadays, computers have so much memory. Most things are running in the cloud. You can just scale things up. It's actually beneficial for us to write software that's optimized for the next human, not for the computer. And then when it comes around to updating a piece of code, it's a lot more well-structured. Productivity is going to increase there again, because not only has it been easier to create it, because we've got a clear idea of what we're building as we're building it, but it's also easier then to pick it up in the future and be more productive when we're maintaining that software. We also have reduced cost, and this kind of goes hand in hand. If you are spending less time maintaining and getting your head into the code, you can spend more time on the cost. So the return on investment there changes. And you can see I'm starting to use what some people might call weasel words or bullshit bingo words. But yes, return on investment is something that we as software developers do actually have to think about. And we get better software quality. If it's more readable, then as we're looking at code, and to somebody's point over there, code should be comments. Yes and no. We'll delve into that, but by and large, yes. If the code is more readable, then it means that as you're going through software, if you find a bug, or even if a bug hasn't been reported, you might read something and go, hang on a minute, this here doesn't really seem quite right. If the method name is give me some kind of information based on X, Y, and Z, and the code inside there tells me the story of something else, it's easier to pick that up. So clean code is going to allow us to write more secure, less bug-ridden software as well. And finally, it gives us testable code. Now, there's an argument about how granular you will make your software components, like the functions and procedures and methods. But if you have everything in one big function, it's really hard to do any kind of functional testing on that. If you break it down into little parts, it's easier to test, it's easier to reuse, which goes back to maintainability, but it's easier to test as well. You'll be able to put test suites in, which then feeds back into the better software quality and et cetera, up the chain. So every single one of our benefits actually links into the others. We're basically giving ourselves a huge opportunity to create much better software that's much more maintainable, and the next person who looks at the code is not going to hate you. We're touching on becoming a hero. Okay. So what do you notice about these four? They're not written for a computer. They're also not written for us as developers. Our managers would love to see these. Now we're coming into justification. Oftentimes, from the security background, one of the things I'm sure we all face is that question of how much time do we spend making our code more secure? And it used to be that we would add security as a feature into a backlog item. Like, we've written a piece of code, now here's another ticket for making it secure. And the problem with that was we would have a Friday delivery date, and a project manager or product manager or release manager would come along and say, hey, Ben, we really need to release on Friday. Can we push these tickets out until next week? And they were all the security ones. And you're like, I really don't think that's a good idea. And they're like, yeah, but we don't have a choice. And rather than pushing deadlines, unless they're absolutely hard deadlines, rather than pushing deadlines because it would look bad, they would release insecure code. Lost my train of thought for a second. So, yes, what do you notice? Oh, I'm using a different clicker. I'm used to a forward-backward clicker. Let me just go back and find the actual right line. Here we go. So what do you notice about these? These are all justifications for our bosses. They are going to push back on anything that's going to cost more money. Not necessarily all the time. That's a blanket statement. Not necessarily true all the time. But by and large, if you want to justify something, you need to get a manager's buy-in. And if you can give them justifiable reasons here about why doing something like this is going to make your software better and more secure and make your life easier in the future, they can see an advantage there. So, techniques for writing. We've looked at the benefits. We are starting to look at some of the justifications that you can use to get our managers to agree to this. What are the things we can actually do now as software engineers to implement clean code? So there are 4 main sections that I'm just going to name, and then we'll go through some examples. So the main things you will want to focus on are things like naming conventions. That's functions and variables. What are they called? Does it make sense to you as you're reading it? There's code formatting. Is it clear and concise? Do braces align so that you can actually tell where the loop ends? There's code organization. Have I split things out into modules? Are those modules in separate files? Are the files well structured in directories? Can I easily find things if I need to find them in the future? IDs will help you by being able to chain through those functions, but having a clear construct in your brain of where those files sit as well can often help with understanding of the code. And finally, comments and documentation. And as mentioned before, comments can sometimes be bad, and sometimes they can be good. We'll have a look at an example of those in a second. So, first example, long and complex functions. Can somebody tell me what this does? We have a process order, which takes an order. If the order is not null, so therefore there's something in there, then we can probably find a status on it. So if the status is pending, then we're going to have a look at the items in that order if it has any. And if it does have items, then we want to make sure there are more than 0 of those, because there's no point in fulfilling an order that has an item with no count in it. And then for each of those items in the order, we're going to make sure that the item actually has information in it, and if so, is the quantity more than 0. So I'm thinking this is probably like a shopping cart or something. And then what we do is we instantiate a product based on the product ID of the item, and then if the product actually exists in our warehouse, as in it exists in the database so we can look it up, and we can get a stock from it, and the stock that we have in the warehouse is greater than or equal to the quantity ordered in the order, then we reduce the stock count by the item quantity, we update the order status to processed, and we save that. It's not actually that complicated, is it? But it took a bit of brain jigging and holding variables in place and looping in my brain to work out what was going on. It would probably take about a minute to work it out. It's not overly complex. But imagine this code instead. If the order is valid to process, then process it. Cool, I know exactly what's happening now. If I want to fix either of these, there's probably 2 things I want to do. I either want to change the definition of what a valid order is, or I want to change what happens when it gets processed. So I've already halved the amount of code I need to look at. If I want to change the definition of whether an order is valid to process, it's right there. There are 3 conditions, and it'll return to true or false. Much easier for me to be able to look at that in isolation by itself. If I want to change what happens when you process, you can go through and you can see that it loops through all the items, and if those are valid, then it'll process the items. Again, contextually, my brain doesn't have to think. It's just reading a story. We can change the definition of whether or not an item is valid to process, and we can change what happens when you process the item, and we can change whether or not a valid product has stock in count. So we're separating all of this out. Now, this is possibly an extreme example, but it's an example to point out that there are ways to make code more readable, even if the first time you look at the first piece of code that we looked at, you might think to yourself, that's actually quite readable. It tells a bit of a story. But I hope you would agree that this tells a much neater story. This is a story you can tell your grandchildren and it won't confuse them. Lack of meaningful names. Who can tell me what this function will return? Average. Excellent. That took probably about 8 seconds. Who can tell me what this function will return? I'm disappointed that it's taking more than 8 seconds, but I hope you get from the example that it says calculate average. It tells you right at the top what it does. And again, we go back to this whole thing of not needing comments. If you look at that code there, it was fairly quick to work out that that was an average. It's probably even quicker to know this is supposed to return an average, look at the code and go, yep, that checks out. If there was an error in that code, you'd probably pick it up pretty quickly. If this was wrapped in a larger context of a larger function or a method, you'd be looking at that going, that does something, I'm not quite sure what. Overuse of comments, to our friend over there. I think you can probably all tell me this will calculate the area of a circle, because that's the first line. Could you tell me that either of these would also calculate the area of a circle? Probably. And I put 2 examples up here, because here's an example in my mind of something that's over-optimization. I would argue that the top example, where you actually specify that it's pi times radius, is clearer than the bottom one. Because in the bottom one, you need to know what math.pow does. And the first time I read math.pow, I thought, is that something to do with a Batman cartoon? So clean and clear code isn't necessarily making it the smallest code possible, or even the most efficient. I haven't run any stats to work out whether math.pow is faster than radius times radius. But even if radius times radius was slower, I would argue, go with the one that makes more sense, that tells a cleaner story. All right, lack of consistency. This one here, a bit of C# for you all. It's fairly straightforward. It's really easy, simple, doesn't really do anything spectacular. But already some of your heads are probably looking at that going, I feel dirty inside. There are 2 issues with this code. One of them is consistency, and the other one is what happens when you have inconsistent code. So you probably figured out that it was mainly about the fact that sometimes there's an underscore, sometimes there's a capital. There are standards, and each language will have its own. Some languages don't have standards, and it comes down to the project or the team to make up the standards. But there should always be standards, conventions of how you name things, how you do you do an incrementer plus plus, or do you do A plus A? Do you put semicolons to the end of your JavaScript? The answer is yes. Or do you choose not to? But the other issue here is, if you look at that last circle on the bottom right, if I'd come in and this class already existed, and somebody said, look, we need to add another method called getFullName, which I would have used a capital G for, of course. If I typed in first name, camel case, first caps, plus space, and then typed in last name, my brain would type in capital L, A-S-T, capital N, A-N-M-E, because my brain is trying to maintain that consistency, and now I've introduced a bug. I'm using an undefined variable. And yes, IDEs would probably pick this up. If they didn't, I would hope your CI/CD pipeline would pick it up. But the point is that it shouldn't have to. Code completion will probably also help. But making everything consistent in the first place just means there's one less thing we have to think about as developers. So that's the nice version. All right, let's put all of this together and have a look at some nasty, nasty code. This is a bad code example. Do you know how I can tell that? Yes, because it tells you in the class name. OK, so what are we going to do? We've got this main function. We're going to load the user, and then it says that we're going to load a user. Great. It's like I've got an echo while somebody's telling me a story. Check if the user is active and authenticated, and then we check if the user is active and the user is authenticated. Count attempts. I would argue that declaring a variable and assigning the value 0 to it counts nothing. So that's a really shitty comment. I think if you just got rid of that comment, you'd probably understand what attempts meant. While attempts is less than 3, we're going to check input. Check input. If we look at the check input function, no, I don't know what that does either. It just checks if the user input is valid. But the function name doesn't tell me that. It's like, does it exist? Is it non-blank? Is it valid? Has it been escaped? Is it ready to go into a database? What does check input mean? Give it a better name. And then I put in a comment there with lots of code because I don't want to actually put lots of code in. But imagine there's a ton of code in there now. We've checked the user input. Whatever that returned was true. Therefore, we're going to do all of this stuff here. So yes, these things here I do not like. What would we do instead? I would argue that if the user is authenticated, then they are also active. You cannot log in if your account is not active. So I have moved onto the right-hand side there. You can see the is user authenticated. I've moved is user active in there. And this is also a really good way of speeding up some of your calls to functions. If the user is not active, you don't need to go through the bother of checking to see whether they're authenticated. You can just return straight out of that with false, and the rest of the code doesn't even need to run. So we've got an optimization there. But the only thing we really care about is my ability to speak. And the other thing we really care about on the left-hand side is the user authenticated? Because that implies that they're active. Make it easier to read. Also, let's take all the operations we want to perform and put them into another function. Some of you might argue that perform operation is a really bad function name, and I would agree with you 100%. That's why it's a code sample, because I don't know what the function does either. And finally, you might have noticed on the previous slide, nope, wrong button again, system error print line. How many of you have more than one system error print line in your code base? Be truthful. 3. Good. If you move that into another function, and in this example, it's part of the same class, but you can move it into a different class. You can have your own logging class. Then allows you to not have to go through your code and get rid of them at the end of the day before you push into production. You can say, hey, if something happens here, log this. If I'm in dev, in a development environment, then I wanted a system print line. If I'm in staging, I wanted to push it into this external logging tool that we use. If I'm in production, I want to push it into something else that's going to probably be a bit more judicious about what actually causes a flag and then alert us that something's actually wrong in production. You still want the information, but the way you want to receive that information changes from environment to environment. So make it easy to change that for yourself. Clean code and bugs. How's this actually going to help us? So we've looked at ways that we can actually improve maintainability. But how does it help us with the security side of things? This code here is rubbish. Okay, let's work out what this one does. Const h, so we've got this handler, I guess, because there's a request and a response. I'm assuming RQ and RS are request and response. This looks to me like a Node.js Express API handler of some sort. Okay, so we've got this handler, and we've got a request and response, and then P and U are predefined. Ugh, it's dirty. If assuming it's a request is undefined, if it's not undefined, is the type regular? If so, do this mathematical thing. If the type is VIP, so now I'm trying to work out what the hell's going on here. So I'll look at the issue ticket and it says, we've got an API endpoint that allows somebody to start the process for a loan application. And as part of that, we need to work out what interest rate we want to apply to that loan and then approve or reject the process from continuing. All right, cool. Bit more context. So if it's a regular user, we're going to look at a normal divided by a maximum times some number. Yeah, if they're VIP, we're going to make a call to an external system or another API endpoint to check they actually are a VIP user and they haven't just spoofed that bit of information in the post request that came from the web application. If they really are, then we're going to, if they're not, we're going to use the same calculation as before. If they are a VIP, then we're going to give them a 25% discount on the interest rate. Cool. And then we return some stuff. So this is definitely not clean code, because even I'm not sure if I got that right. And I wrote that code as badly as I could. So what would be, where would we start if we got this issue and it said, okay, so some customers are being approved for loans way higher than they should be eligible for. Reproducibility, not consistently. Don't you just love that? How do you reproduce this? I've got no idea, it just happens sometimes. It works on my machine, it doesn't work on my machine. Can anybody see the bug? Does this thing work? It does. So where's my cursor? So you're saying in this one here, the calculation is different to this one here. You've got a keen eye. There it says 1,000. There it says 10,000. Why do we have that number in there 3 times? Or rather, why do we have 2 numbers in there when it should just be 1 number 3 times? Absolutely correct. To go through that and get the contextual sense of what's going on is tricky. So yes, there's the 1,000. What we could do instead is say, okay, we're going to have this function called process loan application. Suddenly I know exactly what it does. Isn't that amazing? The rate is 0. It's probably not a great start, but we'll find out later that you should technically not be able to return that anyway. The user is undefined. If the request is not undefined, then we're going to get the loan-to-value ratio for the rate. And then if it's a VIP, we're going to check they're a VIP. And if they actually are a VIP, then we give them a discount of the VIP LVR discount. How much easier was that to read? Very, Ben. Thank you. All right, finally, and we're getting so close to that being a hero, finally, how can we actually use this to be lazy? This is the only screen I have to show you that is lazy. Also, I've just realized as I glance to my right that that X should actually be a tick. So blame my adult brain. This is actually a good thing, not a bad thing. If you're writing clean code and you're structuring things well and you're naming things well and the information is available to the IDE, most IDEs will actually help you code. Why would you not want help writing code? Why would you not want help writing code? Has anybody here used any of the AI-based coding assistants? That's about 47%. Copilot has been around for a while, and I only used it for the first time 4 weeks ago, because I sat next to a friend who said, "Have you tried Copilot?" And I haven't. Top tip, if you're writing code samples for presentations, Copilot is amazing. But we are now in a situation where code is being written for us. How clean is that code? There's a huge question about how accurate and fit for purpose is that code. And that's why anybody who says that AI is going to steal our jobs, I just laugh at, because I'm like, have you seen what it produces? I mean, it's great. It's a great start, but we still have to verify that it does what it does, right? We still have to look at it and go through and say, yes, this is what I intended. So we might end up with some code like this. And the highlighted parts are the only things that I typed into VS Code last night, as I thought, you know what, I can add another slide into this talk. Create a middleware function that. I was, oh, do you want to check a JSON Web Token and make sure it's valid? I'm like, yes, how did you know? Because that's what everybody does. And I said, okay, create a post endpoint that responds to slash posts and uses check WT and says, oh, I know what you want. You wanted to validate the JSON Web Token. I'm like, okay, I'm scared now. But also, what do you notice about this code? I mean, this would work if you owned dev-3q, 3q, 3q, 3q as a tenant name. And but that would probably work at a quick glance. You'd change that host name, you could commit it, and everything would be fine, right? Imagine coming back to that in the future. It's quite readable. But, well, oops. Why not, this button here, why not get rid of these 2 lines of comment right here? They're not really required. Anybody who has worked with any kind of JSON Web Token validation in an Express endpoint is going to be very familiar with that block of code. Anybody who isn't would probably not be touching that bit of code. Again, readability, fit for purpose for the person who's going to be touching it. Validate the audience and issuer. That's actually incorrect. It's not validating anything. It's just providing parameters to some object. Create a post endpoint that responds to that. That's kind of cool. I'd leave that one in. But there's a lot of stuff in here that I would change. I don't need cache the signing key because cache true tells me exactly that. I don't need prevent attackers from requesting over 5 per minute. Again, I'm reading the code and it tells me that. So we are going to be going into a future where we will be using artificial intelligence to write a lot more of our code. And my advice to you is, obviously read it, make sure it's doing what it needs to be done, or what it's supposed to be doing. If you need to, it might create a monolith of a function. Consider breaking it down and applying clean code principle to it after the fact. Then you can test it and make sure that even though you read through it, it actually still does what you're expecting it to do. But don't be scared of it. Just use it and then clean it up afterwards. So hopefully, if you have a clean code principle or philosophy in your application development already, then using things like AI to help you write code is not actually going to negatively affect. You'll only get the positive effects of that assistance tool. All right, challenges for implementing clean code, because it's never easy to turn around to somebody and say, you know what, we need to add something else to our development process. Nobody wants to add something because that just slows us down. So deadlines will always be things I mentioned before. If you have a hard deadline that you can't push, then obviously sometimes you're up a certain creek without a paddle. But often deadlines can be moved. So think about the pros and cons of if we move the deadline, but we get better code at the end of it. That's probably a good thing, right? Often, if you have clients you're writing for, as opposed to if you're working for your own internal products, talking to those clients and saying, hey, this is actually going to make our code better. It's going to make your product better. It means there's going to be fewer issues in the future. And then when you want changes made in the future, we can do those faster. Most of them are going to be, you know what? That probably makes sense. Let's give it a try. Changing requirements. Again, somebody comes along and says, hey, we want to change this. Now, all of a sudden, not only it's easier to find where you need to change it, but then as you're making those changes, we're often in one of these situations of we just need to get this over the line, right? It's a simple change. Let's just put it in. Maybe you've added some extra lines of code in to improve the functionality of a certain routine that you've written, but you haven't stopped and taken a step back and thought, should I put that into its own component, its own function? Have I put too many comments in? Is this actually readable? Sometimes you'll look at bits of code and you'll get similar variable names, especially when you've got loops in loops, because they're dealing with the same kind of thing. So you might have like a temperature, and then you're looping through and you're looking at the temperature from every hour from the day before and you're comparing with the current temperature. Now you've got current temperature and previous temperature, and it starts getting, and then if you put another loop inside there because you want to do something else, you've got another kind of temperature. So maybe it bears breaking that out so that contextually you can look at one block of code and know exactly what's going on under the hood without having to keep multiple variable spaces and scopes, or variable, the values of the variables and the scopes of those variables in your head at the same time. And code base size and complexity. As code base gets bigger, it's going to be hard to do. We also have two issues here. If you're starting a brand new project, you're in a position where you can say, hey, let's do clean code from the beginning. If you are picking up a project that's got 2.5 million lines of code that has never had clean code philosophy applied to it, and you think, you know what, it would probably be a really good idea to do this, everyone's going to shiver, because do you know how long it takes to clean 2.5 million lines of code? Has anybody here cleaned, I don't know, more than 100,000 lines of code? 6 people, that's cool. 500,000. 1. So I'm just going to go straight and say, how big was it? 2.5 million. I guessed at the beginning. I should have asked that straight away. Congratulations, by the way. I don't know how you did it. It would probably be a mammoth operation, right? The other thing to consider is just do it step by step. If you're going to go in and touch a piece of code, then clean that bit of code. Make it easier to read. Break it out, make it more functional, whatever you need to do, so that the next time you come back and look at that code, you're thinking, oh, I'm so glad I did that. And then when you look at a piece of code you didn't, you're like, ugh. And then you do it to that piece of code. And then you do it to another piece of code. And over a year or 2 years or 4 years or however long it takes, you will get to a point where you've cleaned quite a lot of that code. And the advantage is the code that you haven't cleaned, you haven't touched for 4 years. So you're probably not going to touch it for another 4 years. If it works, don't fix it. If it doesn't work, fix it and make it easier for the next person who then has to look at it again. So it is possible, but don't take it on as one big chunk. So I've called these challenges, but in describing them to you, I hope you've heard that they're not actually challenges. I guess they are a challenge. It's a challenge-accepted kind of a challenge. They are things that we can overcome. There are ways around them. They are not blockers to adopting clean code. So we finish with a business case. How do we actually turn around to our manager, project manager, team lead, and say, hey, I've got this great idea. We should spend even more time on stuff. Add another thing to the process. They're like, oh, I love you. That's a great idea. Can we just ship this thing? Okay, return on investment. Yes, because it always comes down to the money. If you can make a financial justification, it's going to be much easier to sell. It doesn't always come down to the money. Sometimes there are other reasons why somebody might take it on, but if you can also give financial justifications for adopting something, it's going to be so much easier for them to then push it up the line and get that approved. So, what if you spend less time reading, less time maintaining, less time fixing, less time debugging code? That sounds like a good thing. If you can go to your manager and say that, then they'd surely be quite happy. You can even go to them with the stats that we had before. Remember we had this is the chart version before. Remember we were spending 10% of our time on good code. We're spending 51% of our time on bad code. Imagine if we halved the amount of time we spent on the bad code. What would that do to this pie chart? It would increase the good code, not by double, but by 3.5 times. Because statistics are amazing. So if you can go to your boss and say, if we just halve the time it takes to read our code, we can be 3.5 times as productive at the cost of a little bit of extra process. He'd be mad, or she'd be mad to say no. At least I would be mad if I was the manager to say no. I can't speak for your managers. Hopefully they'll be okay with the idea. And lastly, you might be looking at this going, yes, that's all very well, but help is at hand. I've already mentioned things like AI coding. It's going to take that code, the comments, and turn it into code that's pretty much usable. Just need to check it. There are also tools at hand. I mentioned at the beginning that I'm a developer advocate for Sonar. I'm not here on a sales pitch for it, but we are sponsoring. So if you want to come down and have a chat with us, we do have tools that help with clean code. But basically, if I can just finish off by summarizing why you should consider it if you haven't, or if you are, congratulations on being part of the pack. You get self-documenting code, code readability, becomes maintainable, there are fewer bugs, and allows you to be lazy. Again, it's going to type it for you. AI types it for you. Make it clean, make it easy to follow. Colleagues will love you because suddenly the whole team improves productivity. But best of all, your boss will love you. That'll make you the hero. Thank you very much for your time. If you fancy asking any questions, I think we've got some time. But if not, as I say, come down and grab me at the booth. Cheers.